Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we will be learning more about data structures and algorithms as well, because in the previous episode we talked about data structure and algorithms. We talked about the introduction of it, and before I started this new series I also talked about JavaScript, Python, etc. So if you haven't checked it out, I recommend checking out those episodes. But in this episode, we're going to be learning about the types of data structures and a few more definitions that we need to learn before we get into the world of data structures. So without further ado, let's talk about them. So like I mentioned in my previous video, I drawn a table last time to show how a data structures is linked to algorithms, and I've also talked about how data structure is divided as well. So let me just draw the table again, and depending on the table, we'll talk about, or I'll explain you how each type of data structure works. So we have two types of data structures, main data structures. We have linear and non-linear. Okay. Linear data structures is again divided into two types. Just start like this. Okay. So data structure is divided into two main types: linear data structure and non-linear data structure. And linear data structure is again divided into dynamic and static. So now let's talk about linear data structure first. So linear data structure is a data structure where all the elements are arranged in sequence. They are arranged sequentially, and these linear data structures are related to each other. So for example, when you're working on something, each element that is before and after that element is linked to each element in some way or another. So linear data structure is basically that. And in linear data structure we have static and dynamic. So in static data structure, as the name suggests, the memory for the element is fixed. So you can't change the memory, or the memory isn't changed throughout the data structure process, and also it also takes up less space in our computer or whatever you're working on. And then you have dynamic, which, as again the name suggests, can be changed, and it can be changed throughout the code, and its size varies, and it is really helpful because depending on the size and stuff, it also can have less size or more size depending on your computer specifications. Meanwhile, static mostly has a closed, and it has a fixed storage. So that is basically about linear, static, dynamic. So the examples for static, you can say, are arrays, and the examples for dynamic, you can say, are stacks, queues, etc. Right? So that is about linear data structure. And non-linear data structure is data structure where every element is not related to each other, where each element works on its own without the help of other elements. And another thing about non-linear data structure is that you can't run all the data structures in a single run, all the elements in a single run. So that is also about non-linear data structure. So that is the main difference between linear data structure and non-linear data structure. Linear data structure is where all the elements are arranged sequentially, whereas non-linear data structure is where the elements are not arranged in sequential order. So now let's talk about some terminologies that are important to understand data structure and algorithms even more. So let's see. First, let's talk about brute force. So again, as the name suggests, brute force is basically telling the data structure or telling the algorithm to work on a process and try to solve it in a specific way. So what is that specific way? So brute force basically goes through every single possibility that a data structure or algorithm can go through, and it makes sure that the process happens by trying out all the different possibilities. So for example, if you flip a coin, and let us assume you asked it what is the probability that will land on heads, it go through every single possible outcome, or maybe not a coin, but maybe like a dice, and you ask it what is the probability that it lands. It'll go through every single possibility, and it'll try to find the answer for it. So that is brute force. It basically brute forces through every single possibility and runs the code. let us not forget about this. We're not really related. So another concept is recursion. The recursion is when the code calls itself. We talked about this in Java, JavaScript, etc. But recursion is where the program calls itself upon it, and that is basically recursion. We'll talk about it and we'll get to understand more when we talk more and more about this in future episodes. But recursion is basically where the program calls itself. And next you have break and conquer, right? So break and conquer is basically dividing a problem that you face into subsequent problems and breaking it down completely. And in this process, recursion is used. So it is the equivalent of, imagine you get a really big problem in real life. You'll obviously try to find out and break it into multiple parts and try to solve these individual problems. Similarly, this is how it also works in the world of DSA. And like I said, recursion is also used in this. So now, let's talk about two good concepts: time complexity and space complexity. So, what are these time complexity and space complexity? Well, time complexity basically tells us about the amount of time it takes for the code to run a program depending on the amount of data that the algorithm has. And the same works for space complexity, but instead of time it measures the amount of space taken, right? So that is basically about time complexity and space complexity. And then we also have bigger notation, which is basically about how when you set a limit for some code, and when the code is going towards the limit, mostly whether that be a specific limit or infinity, that is known as bigger notation. It's a little confusing, but we'll talk about it in the future episodes. And in bigger notation, we mostly use time complexity. So those are some of the definitions about data structure and algorithms. So yeah, in our next episodes, we'll talk more about data structure and algorithms. Mostly, we might talk about the Fibonacci numbers. But yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, I'll see you in the next one. Bye bye.